Hello again, and thank you for listening to the latest episode of Chatting with the Arcturians. Before we begin, I wanted to bring to your attention some books that we've written that would help expand your understanding of the material that the Arcturians are discussing. The first is called Enlightenment Plain and Simple. It's available on Amazon. It's a relatively short book that will provide you with some elementary tools to aid your personal healing and growth. The second book is called The Identity Model: Understanding and Healing Mankind's Stress and Suffering. It also is available on Amazon, and this outlines the nature of the creation of the Hierophant that we discussed in many episodes of the Arcturian Chat, and provides you with the opportunity to become aware of your own identity and to begin to heal, first of all, the emotional baggage that you have accumulated over your lifetime, and then move on to the beliefs that you've incorporated into your Hierophant to begin to surrender those as well. The third book I wanted to tell you about is called Edifying Children of a Lesser God. It is a little bit more complete than the first two books in that it gives you an overview of the nature of our experience of creation and deals more significantly with some of the topics that we discuss in Chatting with the Arcturians. We have another book that will be released in 2024. It's called The Enigma of Consciousness, and we will be providing you with more information when it becomes available. Thank you for listening to the Arcturian Chat podcast, and we will turn you over now to today's recording.
Hello, our friend. How are you today?
Very well, thank you. How are you?
We are well, thank you. Do you come in the love and the light of the Infinite One Creator?
I do, thank you. And do you also?
We do as well. We understand that you would like to resume our discussion from our previous chat?
Yes, we concluded our previous chat with the hint of discussion of free energy, and suggested that be the segue for this episode.
Yes, and there are also there's a few other inventions, if you want to call them, that are sort of in the pipeline. But we'll just recap briefly for the listeners and or readers that are joining us perhaps for the first time or in quite some while. Last time we spoke about how do these people suddenly come up with these fabulous ideas for electricity, or the wheel, use that for example, or how the sun is the center of your galaxy, things of that nature. So we talked about how those people get that inspiration or those thoughts, and the thoughts are already out there, as we explained sooner, or except as we said last time, they're all there. So the thoughts come in as long as the person has a somewhat background knowledge of the basics of what's being introduced, then they have the desire to explore it further and the resources and the additional help required for them to continue on that path should they choose. Those ideas, so this present idea that we are discussing today, we can only speak of things that already are in your consciousness within your population that have already been introduced. We can't just show up and say, this is how you're going to take this care of this problem, build this, and everything will be fine. None of us can do that. That is something that your scientifics must explore, and as the populace must discover and implement as you wish. So
this is a popular topic within
Yes.
our population,
Yes.
and has been for decades. And my understanding is actually more than one system has been experimented with and found to be relatively successful, but for some reason they were not brought to the public's attention.
Yes, and the idea of free energy, it can be implemented in numerous ways. And the ways that have been identified in the past or dismissed and or stolen purely from a greed standpoint for a way to manipulate this wonderful discovery to the population, that if you really want this new thing, we can give it to you, but it's going to cost you. And because we are the only corporation or company that can produce it, we can set our own rates. These things sort of got very distorted with the initiation of giving the information in the first place. It became very distorted and abused. it has materialized into your present system, which is so not necessary because everything that every one of you humans needs to survive is already in existence. There is no reason to produce your green dollars, paper bills to essentially live. That's absurd. Many societies don't even recognize this sort of monetary exchange system. So from that standpoint, the populace needs to understand that all of this has been available since pretty much day one. It's just a matter of developing the interest, certain level of intelligence and motivation to really harness it and pursue it. And again, many of your individuals in your past have done so. However, they've been ridiculed significantly by the general population to the point of being murdered and or imprisoned for their lives, the rest of their lives. So these are big hindrances for many people to come forward with what they already do know, which has been introduced, but they're worried about their status within your society. So those are probably the two biggest limiting factors for your populace to have really advanced for a much comfortable lifestyle where the majority of your time is not spent concerned about obtaining water, electricity, food, things of that nature. All of that is set up. The design was that there was to be no need for that type of dichotomy, that type of system. The idea was that all of these things are provided. Granted, your populace has to engineer it, but it was set out to be relatively simple. The reason being is that this was the original idea for this experiment, was that enabling all of those necessities for your bodies to survive, if they were readily available, free, and easy to access, you would have far greater time to advance your consciousness level and advance your consciousness and movement along the evolutionary scale much faster. So that was the original design. However, greed and manipulation of the information and things of that have taken it a completely different direction. And because of free will, we are not allowed to intervene and step down and treat you like children and say, go sit in the corner. That wasn't very nice. That is not that's not our role. We just want to say that what we're presenting is not a new concept. Many people have heard of free energy. This is just more of a advanced, simplistic format that can be used and accessible to anybody on your planet. And this is irrelevant of using your sun, because solar energy is big right now within your population, and that's great. But in regions that don't receive much sunlight for half of the year, it's not useful. It's not productive. And their solar panels are great, but they take up such a vast quantity of your land masses that prohibits the growth of plants underneath it because they're not receiving the nutrients that they need in order to grow, produce food, things like that. So there's a compromise there that doesn't have to be, I guess is a better way for us to say that. That compromise to get that solar energy, which is clean, as you say, and more efficient, it comes at a cost of extensive land use. The design was there wasn't supposed to be that kind of trade-off. You weren't supposed to give up land for energy or land for water or vice versa. That was not the design. However, that's sort of the model that has developed from all of this.
Okay.
Our idea has already been presented. Otherwise, we would not be able to discuss it. It's been presented to a few of our scientifics that have been able to extract that thought, or shall we say attract that thought rather, and hold on to it and take the time to analyze it and think about it and really try to come up with a way to make it happen. So that takes a lot of time and energy and access to resources and other scientists that are experts in one particular field and another, and kind of getting the whole gang together to further this along. This idea that we're presenting today is already out there. Otherwise, we wouldn't be able to speak about it. And this concept, we will try to put it in words because we're going to have our instrument draw a picture of it, which hopefully you will have access to. It can be uploaded to the discussion on the internet in some format. Mm-hmm. So we can try to verbalize it, but a visual is much better. So we would suggest just listen to our brief overview, and then when you have access to the schematic, we would suggest that you re-listen to this portion of it describing it so that you can kind of look at it and get a visual of what we're talking about. Because we can tell you all about it, but without seeing it and seeing really all these things that we're talking about, it won't make a whole lot of sense.
Right.
In that respect, we're going to have our instrument draw this first idea that we've been discussing, and essentially we'll just describe it briefly. It's a way to access energy for anybody and anything in your planet, basically. It can work on your cars, your houses, your refrigerators, anything that you plug into a wall, anything that requires a great amount of energy, like producing cars or producing houses or all kinds of manufacturing, anything of that nature. Big ships sailing, all these things, it can apply. That's the beauty of it, is that it can apply to any system that requires energy, and it is not dependent upon one particular thing. It's not dependent upon the sun. It's not dependent upon the wind. It works in combination with all of the things that are already present. So therefore, people that live in those regions that we just spoke of that don't receive sunlight, it doesn't matter. This system will work. It will do the same thing. It will just utilize other available resources to produce the same thing. That's the beauty of it. And also, this system, it can be used underwater for your scientifics that want to explore the ocean floors and the fish and all those things. Mm-hmm. It can work underwater as well. Again, irregardless of sunlight, and it will extract what it needs from the ocean water. So that's why it's such a versatile thing. It doesn't matter about altitude or how much sun is or isn't available, depth, inside the ocean water, its consistency, none of that. It will all be utilized to produce the same amount of energy regardless of what it pulls it from the atmosphere. Okay. So we'll just start with that. Do you have any questions before we proceed further?
So I presume in your introductory explanation that this is not depleting one aspect of our environment in order to focus energy into electric form.
No, you're not depleting one source for another. As a matter of fact, it's sort of a recycling system, because what it does require some form of water. So it will extract that from your room air or the air around you, not to a great deal, but it extracts that water in, and also brings in carbon dioxide. So it includes lots of things, but the amount of water that it may need, or oxygen, or other things of that nature, won't be so significant that it won't be a detriment to your planet in any means. Okay. If anything, it's just converting one form of matter into another, which is what your fossil fuels, as you call them, which is silly, we think. But regardless, it's basically converting one thing into another without a negative side effect, without a leftover that's toxic. Okay. Which all of your present energy systems produce. They use natural resources, but the byproduct is very detrimental and harmful to the health and well-being of your people and the planet. This system will not do that.
Okay.
Okay.
We like to refer to those things as being organic.
Yes.
Yes. Okay.
Yes, organic. Yes, it's this design is not. It won't deplete anything by any means, and it's simple. Our instrument. We will make a joke. We spoke with her earlier about this. She's not very scientifically inclined insofar as mechanical things such as computers of that nature. In respect to that, anybody can use this system.
We won't address that outside of our conversation.
We showed her this image a number of years ago, and she didn't really understand it. But we placed the image in her head for her to perhaps contemplate at a later time when things were less volatile in her present incarnation. Okay. So that's where we are at this point. But the idea being, at the expense of our instrument that we made fun of, not really, but as a joke, this instrument is easy to use for anybody. A child could use it, and it's not harmful. It's not going to electrocute them, things of that nature. If a child puts their finger in a light socket, that's not good. You put a hairdryer in a bath water, that's probably bad too. So all of those problems will be gone. So even a child could use it, and there won't be any detrimental side effects. You won't have to put any child-proofing apparatus on it.
Wonderful.
Okay. Wonderful. All right. We're going to open her eyes and hope that she can maintain our connection. This is the first time that we will have spoken to you with her eyes open so that she can focus on the paper.
Okay.
Okay. And so while we're drawing, if you have a question here or there, don't please, interject, but we would rather show her the image and have her draw it first while it's in her head without being distracted by questions and things like that.
Okay,
if that makes sense.
Why don't we just tell our listening audience that we're probably going to be quiet, and I'll delete this quiet from our published conversation.
Yes.
And then pick up after the drawing, and we can discuss it further.
Yes. Whatever you think would be, most applicable and appropriate for this present conversation. Okay. All right. Okay, we're going to bring her back. Okay, this is a general schematic. We're trying to keep her focused. This is the base. This is a handle, that's a handle, that's a handle, that's a handle. This acts as a handle as well for you to hold on to. This right here is the attachment. Shall we label? This right here, this surface that we kind of made a squiggle out of with lines coming out of it, this is the attachment. This will fit into whatever thing you want to charge. And the reason why we drew it kind of squiggly is to implement that it's pliable. It can fit any shape that you put it to. So whether it's wide, it's almost like, how should we say? The metal that it's made of, it's kind of like a gum where it can stretch. So if the base of whatever, say we'll use your example of your vehicle. Most people can relate to this. The circle, the thing where you put the gas in, or now these days the electric charger, it's round. This can easily spread out, and then it lifts up to kind of fit around that, so it could easily accommodate that. It's like a rubber ring that can vary in any different height to a degree, width to a degree, to accommodate whatever it's attaching to.
So it's a pliable metal.
Yeah, that's the thing of it, is that there is no metal present. Well, we don't say that. That's not exactly true. But we don't have any color. This whole outside area and up here, it's made from a metal alloy, I suppose is how your scientifics would refer to it. But it's a combination of different types of elements that typically comprise some of your metals that you use to make pipes or jewelry or cable cords, things of that nature. But this incorporates a new sort of like an element, but a new combination. This is a better way to describe it. We're trying to keep this as simple and easy to understand as possible. It's a new combination of different metals that are lightweight. And the color, it's not like any metal color that you are aware of right now. We're going to see if she can kind of describe it. It's very much, it's similar to a copper color, but a little more red to the copper. It doesn't turn green like copper does, but it has a shimmer to it. And this is the coil. This is what produces all the energy that goes up. And then it collects in here. This is sort of like the collection point right in here. And then it funnels out to whatever it needs, it. So this is where it collects up in here. Once it funnels up, it collects. It can only take so much, and then it'll say no more. It won't let any more in. And so it's never going to implode. It's never going to take on too much to the point where it's going to explode. That's never going to happen. Same thing here. This is the coil that sort of attracts all of these different elements that can come into it. This acts as a sort of like an osmosis, like an osmotic barrier, but not really. It only lets things in one way. This is sort of like your one-way valve. So it only lets things in one way that it needs right here. So it comes into these long lines right here. These are external to the coils. This is the collection point. And the reason why there are so many, and there will be a little bit wider, is to increase the surface area in which it can attract these things and they can sort of stick to it. So the reason for all of these lines, they're more like plates, but they're like this portion would be thicker than the plate. So it's almost like if you picture like a train track, like you have the outside, and then the inside is kind of where all the workings are. So all of this increases the surface area. So this whole thing, we're showing you kind of like if you took the outer layer off, this is what it looks like. So this whole surrounding thing is that metal color we described. And all of these crisscrosses are all to increase the surface area into which these molecules can come in and combine to. Again, similar to the extraction area, the collection area is like a one-way valve. Same thing here. It will only let things in. It won't let things out per se. So whenever it's, let's say, low, for example, let's say you attach it to your vehicle and you drive 1,000 of your kilometers, for example, then this will deplete and it will naturally keep bringing in what it needs and it goes out this way. But say, for example, your vehicle is just sitting in your driveway for a few days and it's windy out or it's sunny or you drove it quite a bit the other day, these cylinders can be full. You don't need to recharge them. Once all of these things are in place, they stay. It's not like your cellular telephones and other such items that have a battery that only lasts so long. That will not be a concern.
It doesn't lose its charge.
It doesn't lose its charge. It keeps it because this is that same metal that we described. And this is the outer kind of wall, and it's made kind of like it's the same metal, but it also has sort of like a rubber component. I suppose that's the best way. If you picture rubber, how it keeps things in, like a balloon, it's a rubber balloon, it keeps air in, things like that. Mm-hmm. So that's what this is. It's like it's seal. It sort of seals it on top of the metal thing that's already there. And this whole system right here, this here and here, all of this is pliable. It can go in, it can go out. For example, if you have a really big hand, you don't need it really small because then it's hard to grip. If you have a tiny hand, it'll we don't really know how to say this. It will conform to the shape of the user. For example, if it's really wide, like a soup can, and that's too big for somebody to hold, and it's they can't get their fingers around it for whatever reason, they can just give it one squish, and then it'll mold to however flexed the fingers and the hand can become around it. So it's pliable. So it's applicable to, as we mentioned, kids, but they probably wouldn't use this until they're in their early teenage years. But this right here it's pliable and it can be used by people that don't have a lot of grip strength or that don't have a wide grip. Any of those factors are addressed here. So none of those concerns there's nothing to worry about in that fashion. Whereas your present systems, like if you go to charge your car, you have to be able to hold the connector and hold it in and twist it or however it connects. You have to have that certain strength in the wrist and the hand to pull it, you push it in and pull it out, things like that. That won't be a problem. That won't be a problem here. And all of these different things that are sticking out, they're different adapters that will fit into, for example, your car, your house, your manufacturing centers, your boats, your submarines for underwater, for that matter, or. So
you take your mobile energy source with you, and it's adaptable to whatever connector you need.
Yes, it does it. Yes, it's completely mobile, and these are handles right here. This is how you can hold it, like if you want to insert it into something or pull it off. And this is sort of like a big handle too. Now, it does require some charging, not a lot, but depending upon the use, it's not completely, doesn't completely hold 100% of the charge 100% of the time. But for the most part, it does. But this right here is your charging apparatus. This big pyramid. The pyramid, okay? This is sort of the charging apparatus. This is when you're not using it and you don't want anyone to you don't want it to lose it or break it or whatever. It goes in this triangular charging station. We call it a charging station because that's the best representation that the majority of your populace will understand insofar as it getting charged up. But this doesn't really conduct anything. It's not like a wire sticking out or one of your phone poles going, it's nothing. It's nothing like that. It goes over it, and it acts in it, and it also regulates how much is coming in based upon sort of how much is left inside. So it's a static station, I guess is the best way to describe it.
But the pyramid's not connected to anything. It's freestanding. In the Raw Group's communications with the LL Research people, they went into some degree of explanation of how energy flows into a pyramid and cycles through the pyramid in the different funds. So is this capitalizing upon that flow of energy through the pyramid? In any way?
Yeah, their description was given in a very it's a more simplistic version of this, given the time frame that the information was given to people so that it could reach a larger group of people to get them to think about such things. So the pyramid was the big kind of introduction to all of that.
Okay.
So the pyramid, as many of you know, this is like a natural, like homing beacon for energy and things of that nature to come in.
Collector and focuser of energy.
Yeah, that's primarily what it does. And so all of that comes in through this pyramid. It's just it's the perfect design to bring everything in from the bottom, concentrate up to the top, and then release it out to whatever needs that sort of energy.
Okay, but the device you're designing absorbs electricity from the environment without being in the pyramid. Is that correct?
It can. Mm-hmm.
Okay.
Yeah, it can.
And if I may, for clarification purposes, for our listening audience, what we're looking at is essentially a thick-stemmed champagne glass, and the cylindrical part of the stem is solid, this new metal that you're referring to, and it has banding around the outside that you said can either be in strips or in wires. Is that correct?
Well, this is the shape of it. It's pretty much, it's like, well, okay, we'll just say it for simplicity. This is relatively one sheet, so to speak.
Okay.
But it's divided. So these divisions, it sort of acts as a channel to bring it in. It makes it a little more effective and efficient for the outside elements to come in. So
this is not a solid cylinder.
It is.
It is a solid cylinder. Yeah. Mm-hmm. And then outside of the cylinder, there is banding?
No, the banding is all within it. This is
or
where
internal. It's internal.
It's internal. It's internal.
Okay, and then within the cylinder,
and within
there's
that,
coiling.
You have the coiling,
and that is also a metal.
Yes. Mm-hmm.
Okay, and there's that the density of that coiling, or how much coiling is that?
You mean in relation to size of the big coils?
Well, is this tightly woven coiling on the inside, or spacious coiling?
The small one in the middle is tight, and this is a slight variation of the metal that the rest of it's made of. This is highly conductive.
Okay. Far
more conductive than any presently known metal, and it's more conductive than the whole surrounding area. It's kind of the charge point. It's like it's where everything gets together and then gets fired up. So this is the main sort of stem goes up here and spreads out. But these coils sort of help push all of these molecules up. It's sort of like a ramp, like a freeway in a circle going up to the top, and then there's your exit.
So there's a central coil, which is relatively speaking smaller than the outside coils.
This is it's a very dynamic coil. It's very highly charged, highly sensitive, and we would say highly sensitive, but it is like this is the key point of all of it right here is this central coil.
It's highly conductive.
It's highly conductive, and everything else, like we said, these panels, they are internal, but then these are the most superficial of all of the things inside.
Okay.
So there's this layer, okay, then there's the big curvies, as we call them. That's the next layer. And then in between the center of all of those other coils is this smaller coil that goes up. So this is the most internal feature of the device right here. That's the most internal. And then it goes out. And again, this right here, this is just more of like a buffer between the inside and the outside. This is kind of like a buffer, but it only lets things in. It doesn't let things out because everything comes out up here. Okay. So these elements and some other ones too, depending upon what environment you're in, these and many other elements will come in, and then they get charged and they regroup. All of these, this is another aspect to it too. All of the chemistry of molecular structures and all of that it will be highly revisited in your future because these present models are somewhat correct but very rudimentary. And so what we mean by that, we'll divert just for a moment here. There are molecules that your scientifics have relatively discovered, but have sort of dismissed it because it doesn't fit into their present paradigm of how molecules form, like how hydrogen combines with oxygen and necessitation of giving up electrons and protons and blah, 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 vice versa. That's a very sort of rudimentary understanding of molecules. So, and they all have a 3D shape, as most people have seen in the electron microscopes and whatnot. All of these elements look like a ball. They all have like a three-dimensional shape. You've seen these. Okay, not all are like this. Okay, not all. There are flat elements. And these are they're a lot like your galaxy, which everything is repeated in nature, as we said before. Everything is repeated. There's synchronicity in everything. So these other molecules, we'll refer to them as flat molecules. They're like a disc, just like the center of your Milky Way is like a disc. Mm-hmm. It's thin, but it goes out a wide area, wider than these molecules, obviously. So it's like a thin disc. And the way that these molecules attach, it's almost kind of like little bubbles on here. And so they go out this way, and they're all flat. Okay, this is a schematic as if you were looking down on it. This is like if you're looking down on it. If you were to turn it this way and skew it a little bit, it'll look more like vertical, like these things won't be as prominent. But nonetheless, this is a very rudimentary diagram. But these molecules are key to many of your upcoming development to assist the population with living a better lifestyle, for example. And the main reason for all of this, the main goal for all of this, it is to essentially to free time. That is the main reason for this, because all of the other systems that have been presented have been abused and have just been completely morphed into something that it was not designed to do. It does what it was intended to do. However, how it's distributed to the population and who has the rights to manufacture it and whatnot, all of that became very extremely distorted over your history. And so the hopes of this is to eliminate that. The initial development of this, of course, will require capital, as you call it. It will require some investment, some scientifics and it will require multiple different specialties of scientists to put all this together. Now, the other trick is to getting all those people to work together and to not be so headset. Well, not to be so ingrained, that's a better word, not to be so ingrained within their particular science that they are unwilling to, they may say, oh, that's a nice idea, but that sounds silly because this is my training and this is what I know and this is what I've seen and I know how it works. This doesn't make any sense, so I'm not even going to address it. That's a big hurdle to get over. But this system here is going to require a lot more scientists to collaborate to figure this all out.
Okay, but this is the functioning of this is contingent upon the availability of the new metallurgy. Is it not?
Yeah, this metal. It's everywhere. It can be made out of all different types of metals. It's just getting the ratio correct. But it will save so much of your resources. And if you think about it, I mean, you wouldn't need gas stations anymore. Think of all the space you could free up from that and all the potential dangers of gas leaks and all the detriment of creating gas in the first place and, taking oil and transforming it into something else. All of the residual of that is very detrimental to humans as well as the planet. So this will eradicate a lot of that. So that's going to be another hurdle for your populace to come to an agreement upon.
Okay.
So this presents many challenges first to be developed. Well, let us rephrase this. First, to be acknowledged. It's already been recognized. It's already sort of out there. Scientists have sort of thinking about it, but not really taking it too seriously because they're being paid to do something else. That's kind of the bottom line anymore, is the money. So
this is their night job.
Yeah, this is kind of like, oh, that would be really neat, but if I present it to the board of this particular energy company, they will dismiss it and think that it's probable. They will think, yeah, this sounds great, it's probable. But if this were to happen, all of our oil production facilities and all of our oil platforms in your oceans and all these different countries and all the people that employs would be shifted dramatically. And so monetarily, from that standpoint, it's not worth their money or their time to pursue this. So there's going to have to be other aspects or contributing people with lots of money, which is it's a bad system that has developed, but it is what it is. But so the money will have to be generated from somewhere, and a lot of your scientifics will have to donate their own time if they really are interested. See, that's the thing of it. This isn't going to happen overnight. It's very complicated. It can be done, but it's going to require a lot of diligence and a lot of your time to put it all together, and that time maybe have to be given. Nobody's going to really pay. Donated, yes, this is a better word. Nobody's going to sit down and say, okay, well, I'm going to quit my job at this pharmaceutical company that I'm in new medication production development. This is my job, and I'm a biochemist, and this is what I do. They make a lot of money, so they're not going to give up half of their time to work on something like this because it's not in their interest. They're not getting paid. That's going to be a hurdle to overcome. It can be done, of course, but see, it's more of the societal difficulties that are present that are going to impede the progress of this, as with any of your major advancements. That's pretty much how this system works. Now, again, the pyramid, now let's say you don't have access to your pyramid. Let's say, and this pyramid, depending upon its location, anyone's pyramid can work. You could put this in your neighbor's pyramid, you could put it in then somebody in Africa and their, pyramid, doesn't matter.
It's the shape.
It is primarily shape. Well, it's a little more than just the shape. It's also what this material is. This material is very important as well. Okay. But so it's the shape and the material. But aside from that, there are no specific USB ports, certain sizes that only fit in here, so we can change the system to make more money so that more people have to buy new cables. None of that will be of concern. That is sort of how this charging station will work. Now, as a backup to that, say, for example, you are driving somewhere, a very remote area, there's no building or people or any type of what you would refer to as civilization for hundreds of miles. What do you do then? You still have this, but you don't have your pyramid to kind of help keep everything in. It's not going to all leak out at once, but it's not going to keep everything in as efficient as it would if you had this. So another option that's built in, you have this platform at the bottom here. Okay, this is within these two central lines right here, but at the base it can be pulled out. So it's already here, but it can come down and be pulled out, so you have more surface area.
When you say pulled out, you mean expanded?
Yeah, like it'll come down, and so you see this thick portion here. It can be, yes, pulled out, expanded, so that you have more surface area, and you can attach it to the ground. So if you don't have the pyramid, and let's say that the atmosphere relatively is devoid of solar, for example, and so you have some of these aspects that are limited, you could plug it into the ground. All you have to do is set it on the ground, and then the electromagnetic current of the ground will do the same thing.
Okay.
That sort of becomes alleviated. So if you were to travel for any great distance or length of time and you're in a hurry and you forgot this for some reason, you're fine because you just take it out and put it on the ground, and then it'll come right up the same way.
Does this, understanding the function of this is a constant source of energy, does this need to be combined with a battery storage system?
No.
It does not?
No. The battery storage, that's kind of like what this is. If you
the pyramid.
If you kind of want to put it like in a little charging station, it may not need charging, but that's kind of like his little home. It is beneficial to use this on a regular basis, but again, if this is not available for whatever reason, the ground works just fine.
Okay, and the size of this device would vary according to the application?
Yes, and this again, all of these defined panels are all variable. They're all flexible. They can all expand, contract, extend in length, things. So all of these are not static parts. They are flexible, like a spring. Like, for example, if you were to have a spring and it's really tight and you want to connect one end of the spring to the other side of the room, you got to stretch it. It has the ability to do that. But when it's not doing that, it'll be a smaller size. So that's the same sort of rudimentary concept behind this.
Okay.
If
and
you
the
could
size
visualize
varies the amount of electrical energy that it can produce?
Not necessarily, no. No, pretty much this one size will fit into pretty much any of your common day uses of houses, manufacturing, large office buildings, grocery stores, homes, cars, things like that. Anything beyond that, and those larger structures may require 2 or 3 of these.
Okay.
So more might be required to power some gigantic manufacturing system, for example, like a car plant that's being developed in your vicinity. So that would require a few of these in strategic areas,
strategically placed.
Strategic areas to create that much energy.
Okay, does the metallurgy deplete?
You mean, does this lose?
Yeah, the coiling in the metallurgy, does it deplete with continued usage?
No, it doesn't degrade.
Okay.
It doesn't degrade. That won't be a problem because of the consistency. It doesn't degrade. So that's why we're saying this can go into any environment. It's not going to degrade, again, because if it's put in more of a hostile environment, like your oceans, this acts as like a protective barrier to anything in the ocean that might affect this in a bad way.
So once you have one of these, then it's a perpetual energy source.
Yeah. Constant, yes. Okay. And again, it's regardless of your amount of solar availability, water, for example. If you're in a very arid area of the planet and there's no humidity, it can rely on these other systems to make up for that. It is applicable to virtually every environment on your planet.
The metallurgy that's required for this, is this subject to our scientists discovering what that is, or can you give us guidance on that?
It would not be appropriate for us to discuss this at this time. It already is in motion. However, we cannot just give you the answer.
Okay.
We can't do that. But now that it's already out there, we can present it to the population because it's already being investigated by more than a handful of people. If it were only one person, we would not be able to throw this out there. But because it's seriously being considered by many of your scientifics, we're allowed to present it in a very general format to the population.
This is intended to be general information for the population, but also affirmation for those that are already working on it.
Yes, if they're inclined to listen to the information that we're presenting, yes. But they will see their own proof as they continue to develop this, as long as they can get past those barriers of the ego mind saying, I know better because I studied this biochemistry for 15 years, so I know more than the engineer who may have studied structural design for 20 years. So that sort of conflict is going to have to be assessed. So that's going to be the ego. Within your level, within this density, the ego mind is always the one to have to overcome.
Okay, that's exciting.
Yeah, it will be a challenge, but it can be attained. But again, it's that ego mind that's going to get in the way, and also just ensuring that this doesn't just end up in the hands of one particular developer, or one particular country can only produce this, so everybody has to give them money for that. So those are things. This is why this is being presented to many scientifics throughout the world. It's being presented to scientifics in Japan, in China, in different parts of Africa, and in the southern portions of your South America. So it's being presented around the world to hopefully bypass that potential.
Okay.
Pretty much the majority of things that could potentially go awry with this have already been considered, which is why much of this has already been divulged to a variety of people and a variety of different cultures.
Okay. Very good.
So that's sort of in the works right now. And these are all just the different molecules that get converted from these. We won't get into all that. That's very in depth and not necessary for the basic understanding of this. That's not required. Okay.
Excellent. Thank you very much.
Okay. Well, it was great to have this chat. We're glad that our instrument was able to focus and draw.
Well, she's been practicing her drawing, I think, in getting ready for this.
That's one way to put it. See, we are adopting her sense of humor, and it's okay for us to utilize such examples, just to make it a little more
entertaining,
a little more fun at her.
Well, I'm grateful for your developing sense of humor.
Yes. Our instrument's getting tired. Unless you have any further questions on this particular design, or if you think of anything in the future, we can revisit it. But for the most part, this is about the most information that we are able to provide at this time. It would not be appropriate for us to go much further into this, because that's an infringement upon your development of consciousness, because your consciousness will increase the more that this is investigated, just as with anything else.
Right. I
Okay.
appreciate that. Thank you very much,
Thank
my
you.
friends. As always, it's a delight to speak with you.
It's good to speak with you too.